Hey guys, so remember when I said it is going to get harder? Well, the time has come. In this video, we're talking about power rules. So that's going to be things like raising a power to a power and raising a product to a power. We're going to get into both of those, so let's check it out. So how do you raise a power to a power, and what the heck does that even mean? So let's say you have something like this. 4 to the third squared. So what that means is you're multiplying the term 4 to the third by itself. So that's actually 4 to the third times 4 to the third, which when we did multiplication, we said you just add the exponents and keep the base, so that would be 4 to the sixth power. All right. We have this other term here, x to the fifth being cubed. So x to the fifth to the third power, that's the same as x to the fifth times x to the fifth times x to the fifth. All right. So add up all your exponents, keep your base, that's x to the 15th. Well, have you noticed the relationship here between the exponents you start with and the exponent you get in your answer? They are products. So what you are going to do in order to do this a lot more simply is to multiply your exponents and keep your base. All right, so 4 to the third squared is the same as 4 to 3 times 2 is 4 to the sixth. X to the fifth cubed is the same as x, and then you multiply your exponents 5 and 3 to get x to the 15th. So let's practice this a little bit. Okay. All right. 3 cubed to the 7th power. So this is like 3 cubed multiplied by itself 7 times. Well, the simple way to do that is to just multiply 3 and 7 to get an exponent of 21. So this becomes 3 to the 21st power, which we really do not want to simplify. All right, h squared squared. So that's h squared multiplied by itself. So that is simply, if you multiply your exponents, h to the fourth. W squared to the sixth. All right, if we multiply our exponents here, we get w to the 12th. P squared to the first. So that's just p squared one time. 2 times 1 is obviously 2. 9 squared to the negative fifth. We haven't done much with negative exponents, but the rules for integers still apply here when you're working with exponents. So when you multiply a negative and a positive number, like you would be doing here, 2 times negative 5, your answer is going to be negative. So this is going to be 9 to the negative 10th. Y to the negative third to the negative fourth. We're going to multiply negative 3 and negative 4 to get y to the positive 12th. Negative times a negative is a positive. Don't forget that. 7 squared to the 9th. Multiply 2 and 9 to get 7 to the 18th. And finally, r squared to the third. So multiply 2 and 3 to get 6. All right, let's move on here and take a look at the next idea. Raising a product to a power. So what does that mean? All right, here we have the expression 3 times y to the third squared. This, in parentheses, is a product because it's a multiplication problem. Y cubed is being multiplied by 3. And we are going to raise this entire expression to the second power. We're going to square it. So this means 3y cubed times 3y cubed, which is like saying 3 times 3 times y by itself 6 times, or 3 squared y to the 6th, or 9 y to the 6th. All right, there's 2 bases in this problem. We've got 3 and we have y. So your exponent is going to be distributed. If you remember your distributive property, the exponent gets distributed to both bases. All right, so that's what we do. We distribute, as in, multiply the exponent that is outside of parentheses to both of the bases, and you still end up multiplying your exponents. So 3, as you can see, there's no exponent written here, but we could say that it's being raised to the first power. So in that case, when you distribute your exponent of 2, you would multiply 1 times 2 to get an exponent of 2, and then when distributing it to the y term, you would multiply 3 times 2 to get 6. So this ends up being 9y to the 6. All right? Okay, let's practice it. All right, once again, we're distributing. So think of it this way too. If your base does not already have an exponent, it's just going to get the exponent that we have out here. So we would distribute the exponent of 2 to both bases in here, and so we would get 3 squared, which is 9, x squared. So this becomes 9x squared. All right, here we have 2x squared to the 4th power. So this becomes 2 to the 4th power, which is 16, x to the 8th. All right. Here we have ABC to the 5th. So each of these bases, ABC, 5 is going to distribute to each of those. So we have A to the 5th, B to the 5th, C to the 5th. All right. Okay, this expression here, we have 10 to the 5th, W squared. So the 2 is going to distribute to the power of 10 here. So 10 to the 5th, and then we distribute the 2. So what we have is 10 to the 10th. All right, now this is a case where I could simplify this, but I don't want to, because 10 to the 10th is a lot simpler than what we would get if we actually figured out what 10 to the 10th is. All right, so we're just going to leave it as 10 to the 10th because that is a lot neater. So it's 10 to the 10th W squared. All right, up here we have x squared y cubed to the 5th. So we distribute the 5, x squared and the 5. So 2 times 5 will give us x to the 10th. Multiply 3 and 5 for the y term, and you get y to the 15th. All right, here we have a squared b cubed to the 4th. So 4 times 2 will give us a to the 8th. And then 4 times 3 will give us b squared. So it's a to the 8th b squared. 10x to the 5th squared. So the 2 gets distributed. So we would have 10 squared, which is just 100. So we can write that, no big deal. All right, and then x to the 5th, and we multiply 5 and 2 to get 10. So we would have 100x to the 10th. Here we have y squared, 10 squared to the 4th. So multiply the exponents, we get y to the 8th, 10 to the 8th, which again, we don't really want to expand. We don't want to simplify that because 10 to the 8th is just a lot cleaner than what that would end up being. All right, so that's all for this. Hope that you got something out of it. Thank you.